Hello everyone. Today let's solve the problem number 20, valid parenthesis, right? So here, please do go through the question and try to understand with the example as well. So I'll just summarize the problem so that it will be easier to understand. So we are given a string S containing only the characters this one. These brackets they have given. We have been given a string S containing only the characters this one brackets, and the string is only valid if every open bracket has a corresponding and correctly placed closing bracket. You can clearly see here this is having the uh, corresponding closing bracket as well, right? The opening parenthesis, this one, it has the closing parenthesis as well. Here you can clearly see corresponding opening closing parenthesis. Here the same thing goes with the square bracket and the flat brackets as well, right? So the output will be true here. In this case the output is false because we have the opening this one parenthesis, but we have the this one square closing square bracket here, right? So it doesn't have the these two doesn't have the this one, this doesn't have the corresponding closing parenthesis, and this doesn't have the corresponding opening square bracket, right? So the output here will be false. Here the output will be true because uh, hmm, it has the corresponding closing bracket and this has the corresponding square bracket. So closing this one square bracket, so the output will be true here. So I hope the question is clear. So let's discuss the approach first, and then let's discuss all the edge cases and then write the code and discuss the complexities as well. Here let's discuss the approach step by step here. So here what we'll be doing, we'll be making use of the stack based approach here. So I'll just write here, we'll be making use of the stack based approach here to check the validity of the string. So let's see let's see the approach step by step. First thing is we are making use of the this one stack to keep the track of expected closing brackets. Here we are making use of the stack. Why? To keep track of this one expected closing brackets. This is important, right? This is first step. So just keep this in mind. So let's move on with the second step. So main logic, right, or the core logic. So when we are encountering an open bracket, either accordingly with the question, either it can be parenthesis, it can be square bracket, or it can be flower bracket, right? So when we are encountering an opening bracket, then we have to push the expected closing bracket to the onto the stack. When we have encountered this one opening these opening braces, we have to push the expected closing bracket. For this we have to push this one, for this we have to push this one, and for this we have to push this one, right? So we have to push the corresponding closing bracket, closing bracket, where onto stack here, right? So when encountering the this one opening bracket, we have to push the expected closing bracket onto the stack, first thing here. And also within the second step, we need to consider when encountering a closing bracket. So suppose it might be this one, it might be this one square bracket, or the this one flower bracket, right? When encountering a closing bracket, we have to check if it matches the top of the stack. We have to check whether uh, whether it matches the top of the stack, right? This one we need to check. If it does, we have to pop the stack. So this one, if it does this one, then what we will do, let's pop the stack, right? Else if it does not match the top of the stack here, we will be returning, let's return false here, right? If it matches the top of the stack, then what we'll do, we will pop the stack, else we will return false. These are the conditions that we need to consider. Let's move on with the final one, final step in the approach, nothing but the final check. At the end, the stack has to be empty. This one is important as well. At the end, stack has to be empty if the string is valid. At the end, stack has to be empty here if the string is valid. This one you will clearly understand while we write the code. So this is the approach that we will be going with mainly. First one, what we are doing here, we are making use of the stack to keep track of the expected closing brackets. This one, first step. So the second step here, when we encounter an opening bracket, either this one we are considering, we have to push the expected closing bracket, this one, onto the stack. When encountering a closed bracket, this one, we are checking whether if it matches the top of the stack or not. If it does, then we will pop the stack, else we will be returning false, this one. Finally, what we will do, at the end, the stack has to be empty. This one is very important. So at the end, we have to check whether the stack is empty or not. If it is empty, then the string is said to be valid, right? This is the approach that we'll be going with. Next, let's discuss the edge case one by one and then write the code and discuss the complexity of the code. So here, let's go with the edge cases one by one. Let me give here edge cases. So the first edge case that we'll be going here is, let's consider valid single pair of parentheses here. So let me consider this one, s equals within the string. So we have here the opening parenthesis and the closing parenthesis. So this is for the valid single pair of parentheses, right? This is the first edge case. The second edge case that will be going here is, let's go with the nested brackets. So here, when I say valid nested brackets, let's go with this example. Let me give here this one. Okay, let's consider all the brackets here. So this has to be here. I have considered closing bracket for the closing flare bracket, and finally the closing parenthesis, right? So this is for the valid, this one, nested brackets. So why this is valid here? We can clearly see we have the closing parenthesis here. We have the closing this one as well, a flare bracket as well. We have the closing square bracket as well, and we have the opening and closing this one parenthesis as well. So this is for the valid nested brackets. Let's move on with the third edge case. Nothing but let's go with the brackets in the wrong order. So let's go with the invalid test case, right? So I'll just go with here some random this one. Let me give here this one and this one. Here we need to have the so this is invalid. Why this is invalid? Because brackets are closed in wrong order. Brackets are closed in wrong order, right? You can clearly see here. Here we have opening a square bracket. Here we should have the opening square bracket, but we are having the closed parenthesis. Here we have the opening parenthesis. Here we should have the closing parenthesis, but we have the closing square bracket, right? So this is invalid. Brackets are closed in a wrong order. We can clearly see. So this one. So let me delete this one. Yeah, let's go with the fourth edge case, right? So let's go with only opening brackets. So this is we get the output false here. So basically, this is for the only opening brackets here. This is invalid, right? Only opening brackets here. No closing brackets we are not considering here. So let's go with the final edge case, the fifth one. Let's go with the empty string here. Let me consider here s equals empty string. Let's consider here. So this is valid here. Why? Because empty string is considered valid always. Empty string is always valid. So these are the 5 edge cases. So here, let me come here. So this is for the valid single pair of parentheses. The output will be true for this one, right? So here the second one is we have the valid nested brackets we saw. This is also for this one also the output will be true. Here this is invalid because the brackets are closed in the wrong order. We saw this one, right? The output will be false for this edge case. So here we are seeing only, this is for only opening brackets. We have considered only opening brackets. We don't have any closed brackets. We should have the 4 closed parenthesis brackets as well here, right? 4 closed parentheses as well. So this one will be false. And final one is we are considering the empty string and empty string is always valid, right? So this one will be basically true here. So we have considered all the edge cases. Next, let's start writing the code. I'll explain the code while writing the code itself, right? Let's start writing the code quickly. So here, the first step is, as we had discussed in the approach, we have to define the pairs of brackets and initialize an empty stack as we are going with the stack approach. So I'll just come here, just make use of the variable name pairs. Within this one, let me consider this one. And let me consider this one. Same thing, let me copy and change the brackets right here. So here instead of this one, let me consider square bracket and the flower bracket here. Same, closing square bracket and closing flower bracket. This is fine. We don't need comma here. This is fine. Also, we need to initialize the stack as well, right? I'll just initialize the stack to empty array here. So the next step here is, let's go with the iteration. We have to iterate through the each character in the string, right? I'll just consider here for let C of S, we have the parameter S, right? String this one. We have to consider, we are iterating through the each character in the string. If it's an empty bracket, then we have to push the corresponding closing bracket. If it is an opening bracket, then we have to push the corresponding closing bracket as well, right? So let's write the simple if condition here. If pairs of C, if we have pairs here, then if we have the, as I've said, if it's an opening bracket, we have to push the corresponding closing bracket. Let me make use of the stack and we have to push the corresponding closing bracket as well, right? To push the corresponding closing brackets, I'll just make use of the push. I'll just give here pairs of C. This is fine. So this has to be within the array, right? Sorry. Yeah. This is fine. Else what we will do, if it's a closing bracket, then we will check if it matches the top of the stack or not, as we had discussed in the approach. This is also a simple if condition. We are checking for the closing bracket, right? This one, if stack.pop, this one, if it is not equal to C, then we will just return false in this case. What we are doing here, what we did, this if condition, what is this one? If it's an opening bracket, we are pushing the corresponding closing bracket. Here what we are doing, if it's a closing bracket, then we are checking if it matches the top of the stack or not. That's what we are doing. Finally, the final step is, let's return true if the stack is empty. If the stack is not as we had discussed in the approach, if the stack is empty, then only the string is said to be valid. And if the stack is not empty, we'll be returning false, right? So let's return stack dot length. The length of the stack has to be empty. Means let's compare this one with the 0. So this is it. I hope the solution is completely clear. So let me have formatted the code. Let me hit the run button. So here OS, this has to be off. That's fine. Let me format this one again. Let me hit the run button. So here you can clearly see the sample test cases are getting passed here, right? So let me hit the submit button. So you can clearly see here all the test cases are getting passed. So the code works absolutely fine or correct. So let's quickly discuss the time and this one, space complexities, right? So what will be the overall time complexity here? The overall time complexity will be here big O of when. Why? We are traversing the string only once, and the stack operations push or pop take big O of 1 here. We can clearly see here, we are traversing the string only once, and the stack operations push and pop take big O of 1, right? So overall time complexity would be here big O of n. So what will be the space complexity here? The overall space complexity would be here big O of n. Why the overall space complexity here will be big O of n? Because in the worst case, all the brackets are opening brackets and we store them in the stack. So we had discussed this one in the edge case, right? So in the worst case, all the brackets are opening brackets and we are storing them in the stack. So the overall space complexity would be big O of n. So here overall time complexity and the space complexity would be big O of n itself. So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.